Simultaneous equations are one of the basic principles of maths, which are one of the biggest topics in GCSE maths. Now for the first video on this channel, I thought I would cover simultaneous equations. Simultaneous equations are one of the basic principles of maths, which are one of the biggest topics in GCSE maths. I'm going to go through different questions, each of them getting harder by example, and hopefully by the end you'll be a master at solving simultaneous equations. So the first equation that we'll be doing will be 12 minus 3x plus 2y. Sorry, 12 is equal to 3x plus 2y. And then there'll also be 16 is equal to 4x plus 2y. Now with simultaneous equations, what you are trying to do is you are trying to work out the x values, being these, and the y values. So what are they equal to? Now you'll be given normally two different equations, and you'll have to basically substitute in values. You'll have to subtract values to work out what the x values and the y values are. Now when you get two simultaneous equations like this, what I like to do is I will actually label them. So this is equation 1 and this is equation 2. Now, so what you need to do to be able to do this when you have two different values is you need to get rid of one of the terms. So to get rid of one of the terms, you've really got to either add the two equations together or subtract them. In the same way, if you were doing addition or subtraction, say if you had 13 minus 12, you'd see that 3 minus 2 is 1 and 1 minus 1 is 0, which is 1, which everyone knows. Now, with these two equations, we are going to try and find what the like terms are. Now, you ignore these as these are not, they don't have values after them, so there's no x and no y on them. However, here, there's an x and a y. So we could do it these values, however, we really want to find the easiest way to do it. These values have got the same number in front as there's a 2 on that one, and there was a 2 on that one. Now, what you're trying to do is you're trying to really get rid of one of the terms to work out the other one and then to substitute it back in. Which might sound like a load of nonsense at the minute, but trust me, later in this video you will understand. So here we've got a 2y term and here we've got a 2y term. Now you'll notice that they both have a positive sign in front of them. Now there's a little acronym that you should remember which will really help with substitution. And that is same signs subtract. So what we're going to do here is we're going to subtract these two different equations from each other. So 12 minus 16 is minus 4. 3x minus 4x is minus x. And 2y minus 2y is just 0. And as you can see here, we have got rid of the y value, the y terms, which will allow us to work out the x value. So if we divide by minus 1, we will get 4 is equal to x. So that is the x value for both of these equations. X is equal to 4. Now to work out the y value, we need to substitute this x value back into one of those two equations. You can choose either one, it does not matter. So let's assume that we'll go with equation 1. You can do literally either of them, however I think equation 1 will be a bit easier as they are lower numbers. For example, there's a 3 here and there's a 12 there compared to the 16 and the 4. So you just simply get your equation, 12 is equal to 3x plus 2y. Now to substitute, we know that x is equal to 4, so we can rewrite this as 12 is equal to 3 brackets 4 plus 2y, which then is equal to 12 is equal to 12 plus 2y, which when you take away 12 from both sides, you notice that 0 is equal to 2y, in which 0 must be equal to y. So from these two equations, we know that x is equal to 4 and y is equal to 0. And that is the first one. That is the simplest of simultaneous equations that you'll really get at GCSE. It's really useful because it allows you to work out, so these are equations of lines actually. So it allows you, this isn't a coordinate, so x is equal to 4 and y is equal to 0. This is actually a coordinate on a graph, which would be 4 along, and it would be 0 up on y, so it would just be there. And these two lines will actually intersect at this point. So that's what it allows you to work out in the simplest format. Now we're going to look at a little harder exercise to try and get our heads around it. So number 2. Minus 12 is equal to 2x minus y. 7 is equal to 3x plus y. So you'll notice for this one that when you're looking for the like terms, you'll notice that there is, on both equations, there is one y. However, in the first equation, equation number 1, equation number 2, first equation there is a negative y, and in the second equation there is a positive y. Now, you may remember from the last one we did that when they are the same signs, so say if this one was a negative, or if both of them were positive, then it would be same signs subtract, because they are the same signs, as a negative and a negative are the same, and a positive are the same. However, when you have two different signs, so in this case we've got a plus and a minus, which will always be the case, really, at this level, they're different signs, and different signs add. The reasoning for this is just to get rid of one of the terms. It's as simple as that, because say if you took away y from y, that would just make negative 2y, which wouldn't get rid of the y value. Whereas if you add y to negative y, then it will make 0. So you're getting rid of the y terms. So negative 12 plus 7, because it's different signs. I should have mentioned actually that say if it's different signs for this, you don't just add these two terms, you add the entire thing, you put it all over the addition. So minus 12 plus 7 is minus 5. 2x plus 3x is equal to 5x. Minus y plus y is just equal to 0, which we then know minus 5 is equal to 5x. So minus 1, minus 1 is equal to x. Then, just like before, we substitute it back into one of your equations. You really take your pick here. You could do for the top one or the bottom one. I'm going to choose the bottom one. It doesn't really matter, to be honest. So I'm going to pick equation number 2. So here's equation number 2. 7 is equal to 3x plus y, which, remember, when we substitute in, x is equal to minus 1, so we just pop it into there. So 7 is equal to 3 times minus 1 plus y, which 7 is equal to minus 3 plus y. Which then, when you add 3 to both sides, you get 10 is equal to y. So for this simultaneous equation, we have x is equal to minus 1 and y is equal to 10. Now, we are going to get a little harder here. So for question number 3, 21 is equal to 3x minus y, and 6 is equal to 2x plus 2y. So you'll notice in this simultaneous equation when we label them 1 and 2, you'll notice that there are no like terms. So the value in front of the x and y's for both of these two equations are not the same. So in the last one where we had a negative y on the top and a positive y on the bottom, this time we have a positive 2y on the bottom, which if we were to just add the terms like we did before, negative y plus 2y would make y, which wouldn't cancel out the y. It's the same with the x. It would equal 5x, or if we did it from the x values, then it would be 3 minus 2, which would just be x. That's not cancelling out any terms, which is what we want. So remember, simultaneous equations, the first step is to try and cancel out one of the terms so you can work out one of the others. So what we've got to do here is we've actually got to multiply the entire equation, or I should say for the first one, by 2. And the reason why I'm going to do this, you can actually do it by multiplying the second one by 3 and the first one by 2. There are loads of ways around it. We've just got to make one of the terms the same. So if we look at equation 1 here, you'll notice it is a minus y. And in number 2, it's positive 2y. Now, to get them the same, remember you can ignore the signs in front, so the negative and the positive. You can ignore them. So to get 1y equal to 2y, you can just multiply the first one by 2, in which when we multiply y by 2, we've got to make all the terms, we've got to multiply them all by 2. So we're going to, therefore, we're going to bring this down, and we're actually going to go times 2. Now we're going to label this as equation 3, because although it's the exact same as equation 1, it's just a bit different. So you in the substitution, you'll be able to use that one instead if you want to, which is the reason why I make it number 3. So when you times it by 2, you'll get 42 is equal to 6x minus 2y, which when you put equation 2 here, which is this one here, underneath, which is just the 6 is equal to 2x plus 2y, you can now take this equation away from this equation. So now we've got like terms. It's a different sign though, so different signs add. So we're just going to add them, simple as that. 48, 42 plus 6, 48 is equal to 6 plus 2 is 8x. And then negative 2y plus 2y is plus 0. So as you can see, it cancels out, which is what we want. So therefore, 48 is equal to 8x, in which x is equal to 6. Now the last thing I'd like to talk to you guys about is that the exam may question them as not x and y's, it could be z's and a's, or it could be a's and b's, or it could be apples and oranges. No matter what it is though, if you've got two equations where there's two terms, or if you're doing further maths, GCSE, and you have 3 terms, they're just simultaneous equations and you can take them off each other to work out the different terms. This one, however, isn't finished just yet. We've worked out the x term, we need to work out the y term, which could be anything. It doesn't have to be y, that's all I wanted to say. So we can choose out of really these 3 equations. We've got an equation here, I'll take away that, we've got an equation here, and we've got an equation here. Now, the best out of those 3 equations, I think, is the second one, this one here, because to substitute into this, it'll be a bit easier. There are no negatives, and it's all low numbers compared to this, which has got a negative and it's a bit higher, and this one, which has got negatives and it's higher. So if we have 6 is equal to 2x plus 2y, then 6 is equal to 2 times 6 plus 2y, because we know that x is equal to 6, so we can pop that in. 6 is therefore equal to 12 plus 2y, in which when we take away 12 from both sides, because we want there to be no number here, I'll actually just move this up a little bit. So So when you take away 12 from both sides, you'll get minus 6 is equal to 2y, in which y is equal to minus 3. And that, my friends, is just my first ever video. I've hoped you enjoyed it. I've really hoped it has helped. If there's anything that you'd like me to do, be sure to comment. And if you enjoyed it, leave a like. Yeah, I hope you enjoyed.